through-wall detection and classification are highly desirable for surveillance, security, and military applications in areas that cannot be sensed using conventional measures. With these applications, the key challenge is the ability not only to sense the presence of individuals behind a wall, but also to classify their actions and postures. Researchers have applied ultra-wideband or UWB radars to penetrate wall materials and make intelligent decisions about the contents of rooms and buildings. Examples include Iceni Labs in the UK with SafeScan, but also Camero-Tech in Israel, which recently unveiled its portable Saver long-range system with an advertised standoff range of more than 100 metres. With me to discuss this technology and other military sense-through-wall systems is Camero CEO Amir Beeri. Amir, welcome to the Weekly Defence Podcast.
Hi, Ben. Thank you for inviting me. Very happy to be with you today.
Great. My first question to you, Amir, just a general one. How does this kind of technology for sensing people and objects through walls actually work?
So actually, we are using radio waves. Radio waves can penetrate effectively through walls. This is a well-known phenomenon, and generally we know it from our mobile phones and Wi-Fi. The fact that we can use these devices, it's that just because it can penetrate walls. If not, we will not be able to use our mobiles in buildings, or we cannot use Wi-Fi from one room to another. So we are using these radio waves basically as a radar. It's a radar that analyzes reflections, but not as some other radars that can work in line of sight, like those that detect missiles, airplanes, vessels. We should pass through walls. And we are doing it in another way. We are using generally array of sensors to reconstruct live imaging. We are using ultra-wideband signals, which are extremely wide in relatively low frequencies. The reason for the low frequency is that it can better penetrate walls in low frequencies, and the bandwidth is for getting good enough resolution. We can get, in this way, also very high sensitivity. We can measure extremely small movements like breathing, which is in the range of sub-millimeter movement. But unfortunately, it's not trivial. Walls are not really transparent, also in low frequencies. There is attenuation, there are distortions, occlusions, mirroring, many physical phenomena that exist and we should overcome it in order to reconstruct intuitive image or reliable indication of existing of people in a room or their location.
Can I just interrupt, Amir, and ask you, obviously being able to see something through a wall, limiting factors must include the type of material that the wall is made of and of course, the thickness and extent of the wall, of the construction. How can those factors be dealt with?
Absolutely. All these factors matters. But as far as the wall is not continuous metal, we can penetrate walls. Of course, different walls, according the material and the width and the humidity in the wall, can affect the attenuation. But more problematic can be the distortions. For example, bricks with cavities can cause a lot of echoes that should be overcome. We are in the world of mirrors because walls are not only penetratable, they are also mirroring signals. And when we are entering a room, for example, all walls are like mirrors. So we have to handle these issues. And I can tell you the bottom line is that we can penetrate very massive walls. We can reach almost 1 meter width of walls, depends on the type of walls. Generally, we can penetrate multiple walls, which can help to see deeper in structures. But everything depends on the exact situation. So we have to run massive signal processing and image processing in order to overcome some of these problems we reconstruct the image not in a conventional way. We are doing iterative algebraic image reconstruction, which helps a lot with the quality of what we can get.
Is this based on artificial intelligence, Amir?
Yes, there is a level of AI which is, after all what we are doing here, we are running deep learning algorithms in order to improve interpretation. We are using it more massively in recent years when this technology developed. And this really helps with interpretation, improving and overcome of some of the problems of the physical phenomena that happens.
Yes, indeed. It is one thing for a radar to return a signal.
Absolutely.
But arguably, it's more important to have the right way of interpreting the result in order to get actionable intelligence from the data.
Yeah. In general, if you look on the reflections of what happens through the wall, it can look really meaningless. You have to do something in order to make it intuitive to the user. AI really helps because you can just fill the gap between experienced user that can see things that other will not see and make it available to everyone with a short training and intuitive interpretation.
Yes, you mentioned training. I expect that's quite a sizable burden. Is that undertaken by yourselves, or is it undertaken by the military or Homeland Security agencies?
Generally, we are prepared to do it, but actually our system today is quite simple and intuitive and don't need much training, especially with the advanced algorithms that we're running today. It's very intuitive. Generally, only short training is needed, and the operation itself is very simple. Generally, it's a push of a button, and with the tools of our signal and image processing, we're helping a lot with automatic decisions that the system make the decision of identification, of tracking, to improve the results in a way that it's really trivial.
In terms of what the Saber product can detect, it can detect the movement of live human beings in behind walls. But what about the very important need to detect inanimate objects, such as improvised explosive devices inside buildings? Is that something that you are looking to develop, or is it simply impossible given the limitations of the technology today?
Okay, this is a very good question. Actually, we can detect completely static objects, non-live objects. Generally, we are using it not to detect unexplosive devices, but more to get the internal layout of buildings and to measure size of walls, of corridors. This is a real need of many operational issues. But actually, we cannot identify specific materials, or we cannot detect the exact shape of explosive device to say this is explosive device, unfortunately.
I see. Well, maybe this is something in the future, a few years' time. I understand that this technology that Camero-Tech has developed, as have other developers of sensory wall technologies, these are passive. So there are no safety issues about ionizing radiation, as I understand it. Can you confirm that?
The systems are actually not passive. It's active. We're transmitting signals, ultra-wideband signal, and analyze reflection. But we are using extremely weak signal, very, very low power. We're transmitting in all our systems less than 1 milliwatt, which is spread over very wide bandwidths, gigahertz of bandwidths. So the power spectral density is so low that in really close distance from the system, we are below the thermal noise level. So this is also enters to the category of LPI, low probability of intercept. it's very, very hard to intercept this type of system. It's very low. We are using radio waves which are not ionizing, so it's completely radiation safe. It's order of magnitudes below, for example, a regular cellular phone. And it stands in all international standards of radiation safety. So there is no radiation safety issue in this signal. In the long range, for example, in the new device, XLR, we are also using very narrow beam. So we are very narrow in what we are transmitting. So it's almost impossible to detect or to intercept this type of system. It's very, very low signals.
I understand. And I did actually see a video showing what I believe is the latest long-range system, showing detection beyond 100 meters, but in a totally open environment without anything in the way. So no buildings, no cars, no people. So I had to ask you, Amir, is the Seva XLR, has it been tested in a cluttered environment with lots of other people in the way, other objects, cars, other buildings apart from the building that you're trying to search for?
Absolutely. The XLR-AT was designed to work both in rural and in urban environments. In the short video clip, we show open space because it's easier to demonstrate what it's really doing. But we're using a very narrow beam, so we can be very selective and we can overcome most of the unwanted effect just by using this very narrow beam. But we are using also ultra wideband, which helps us a lot in a clutter environment. As we are using very wide bandwidths, the impulse response of the system is very narrow. And this means that we can clip out unwanted reflections. So we can be selective on the first reflection from the object and ignore all the rest.
I see. And also, Amir, just doing a little bit of background research, and I cannot pretend to know half as much as you do about the technology, but having had a little look at various systems for sensing through walls, the academic literature mentions other kinds of ultra-wideband systems that might be used. For instance, there was some research papers published over recent years that talked about the potential of stepped frequency continuous wave radar technology. Is that something which you've noticed being applied in various projects?
Yes, of course. There are different ways to implement ultra-wideband signal. FMCW or step frequency CW or pseudo noise modulation. There are other methods to implement ultra-wideband rather than pulse-based methods that we are using. Years ago, we considered the different methods, and the main reason we choose to use the pulse-based method is that it provides us much better dynamic range. And this dynamic range means that we can receive very weak signal close to very strong one and still resolve these two. This is very, very important, especially through the wall, because we deal with extremely low signals, while some other signals can be quite strong. And if we will not have this dynamic range, it just will not work well. In the other side, there are some benefits in using FMCW or step frequency. For example, you can transmit higher power. But in our case, as we are interested to keep our system as a LPI, low probability of intercept, and to be comply with the spectrum regulation like FCC and others, we prefer to keep our transmitted signal very low. So we thought the pulse-based is the right way to go forward with our systems.
I see. And you mentioned, Amir, earlier the training aspect. And I'd like to turn now to the human factor when it comes to how the operators use sense-through-wall technology. What kind of human factors issues do arise, if any?
Yes, there are many. If I'll split it to two categories, is one, the interpretation. There might be misinterpretation due to physical phenomena we mentioned, like shadowing, like occlusion, like distortion, mirroring, and some other. But when carrying a system to the field, there are many other factors, like size and weight, like simplicity. The system should be user-friendly, especially for tactical use, both operational side and the graphical user interface should be intuitive and easy to understand. Automation is important. As much as you can do more automation, ergonomic, carrying case, accessories, all this relates to human factors that we have to take care. The system shouldn't be too fragile and sensitive. This is the reason most of our systems are MIL standard. They can work in extreme environmental condition, temperature, shock vibration, etc. All these are human factors that we should take care for.
Indeed, ruggedization is, of course, a prerequisite for military users in particular. You mentioned size and weight a little bit earlier, Amir. Do you see the need or envisage the need to redesign the XLR80, for instance, so that it becomes even smaller and weighs even less? So I'm thinking of perhaps a handheld version. Is that on the horizon?
Yes, of course. But here we have to split the antenna from the electronics. The antenna aperture with the frequency band that we works actually dictates the beam widths and the gain of the antenna. And with the XLR, we are actually projecting a spot on the building. And if we would like to reach more than 100 meters, we need a narrow beam in order the spot will be small enough to be selective, for example, on one building or one room to another room in the building. So the size of the antenna is actually a physical factor that we have to take in account. The electronics in this specific system, for example, is a small fraction of the antenna size and weight. So the antenna actually dictate here mainly the size. But we can definitely think about various ranges, spot size, and antenna size. So, for example, if we will design a system to half this range, we can get antenna which is half of its size, and the area can be 1/4 of the size of the current one. And I can tell you already that in the pipe there are other systems or other antennas to reach different ranges for different uses.
I see. And if you were living in an ideal world, I know we're not, but if you were, how in an ideal world would you improve ultra-wideband technology in general? Is there still room, for instance, to improve image formation, data acquisition, and range?
Yes, of course. Always there are ways to improve, and we have a lot of ideas how to improve everything, from sensitivity up to the quality of the image. One of the trade-offs that we deal with is power consumption against algorithms to improve imaging, for example. And as technology getting advanced, we can get more processing power for less power consumption, because all our system works on battery. And we have in the pipe a lot of ideas of how to improve things. And I believe it will come once we can get better and stronger processing power.
Thank you very much, Amir. Thank you for your time.
Thank you, Ben. Thank you.
This episode of the Weekly Defence Podcast was brought to you in partnership with our sponsor, Bell. A big thanks to everyone who took the time in being with us today. And for our listeners, if you enjoyed the show, make sure you like and subscribe. Leave a review on iTunes, Spotify, Google Play, or wherever you get your podcast. If you want to know more about the market landscape of the defence sector, visit shepherdmedia.com/subscribe and redeem your free trial to our premium news, where you can get international coverage of equipment, innovation, company news, programme updates, and more from our team of expert journalists.